This is CalcPath Geometry, lesson 1-6 of our algebra unit. And today we already looked in the previous clip at being able to solve systems of equations by graphing. Now we're looking at being able to solve systems of inequalities by graphing. So we're going to solve these inequalities. We're going to graph these, and then we'll talk about what a solution to a set of inequalities is. All right, in our first one, we're going to graph this first one. I'll graph that one in blue. It says y is greater than or equal to x minus 3. It is in slope-intercept form, so when I find my points, I'm going to look at my slope of 1 over 1 and my y-intercept at negative 3 to plot the points. So from the y-intercept of negative 3, I'm going to go up 1 over 1, up 1, right 1, up 1, right 1, and continue that pattern for all of my points. So here is, oh, I made a big mistake already. And some of you already know what it is. This does not have equality, so I was supposed to use a dotted or dashed line. So I'm going to do that by making these a little thicker, although it makes it more difficult to see an intersection point, but that's okay. So I'm going to do that by making it black, so I can see it covers up my mistake since it was in pen. For my other equation, which in order of plotting points, I'm going to treat as y equals negative 1/2 x plus 2. My y-intercept is 2, so I will start at a y-intercept of 2. My slope is negative 1/2, which means I either go down 1 and right 2, down 1 and right 2, down 1 and right 2, or I reverse it and go up 1 and left 2. I think I have enough points on there to get a straight line. You really only need 3 if they're in accurate place. And that one does have equality, so now if I trace the straight line, it's okay because it's supposed to have equality. Now I'm going to treat these one at a time. My black line, which I'm going to shade in blue because it was supposed to be blue, I'm going to pick a test point. So here's that first line, this first inequality. It says y is greater than x minus 3, and I have 0, 0, which is not a point on that line, so it's okay to test 0, 0. When I do that, my y value is 0, my x value is 0. So is 0 greater than 0 minus 3? Yes, 0 is greater than 0 minus 3. This is true, which means for this inequality, I will be shading this side of the line. Just going to indicate that by going up a little bit. I'm not actually going to shade it over yet. I would shade it, but what we're going to be looking for, well, you'll see that in just a second. So that point and all the points on that side of the blue line are true for that inequality. Now looking at this inequality, 0, 0 is not a point on it, so again I'm going to test 0, 0. When I plug in 0 for my y, I have 0 is less than or equal to negative 1/2 times 0 is 0 plus 2. And 0 is less than or equal to 2. That is a true inequality. So that means that 0, 0 is also a solution to my purple line. So this side of the purple line would be shaded. Well, I don't really want up here because it's only, these points are only a solution to the blue line. I don't want down here because these points are only a solution to the purple line. And I don't want a point over here because it's not a solution to either inequality. The place that I want to shade, and I will double shade it. If you did shade the whole thing, just do a double shade, is right here. This is our solution set. Solution set being the set of all points. Notice not any points on this dashed line, but every point on this solid line, and all the points in here extending out infinitely following those lines. All of those points will make both of these inequalities true. So this brings us to the solution, the solution to a system of inequalities. A solution to the system of inequalities is all points, or any point, that make all inequalities in the system true. So any and all points that make all of the inequalities in the system true. That is the solution to a system of inequalities. So let's take a look at the next one. We've got a standard form equation. I'm going to do x-intercept. When I use cover-up method, this gives me 5, 0 for my x-intercept. When I do cover-up method here and divide by -5, I get 0, -2 for my y-intercept. So 5, 0, and 0, -2. There is equality, so I will graph a solid line for that. And it doesn't intersect at 0, 0, or 0, 0 is not a point on the line, so it's okay for me to test 0, 0. 2 times 0 is 0, minus 5 times 0 is 0. Is 0 greater than or equal to 10? This is false. So this point is not a solution to my blue line. I would actually have to shade the other side of the blue line. Now my next line is just x. It's like x equals a number, -3. So we remember the expression oi vux. This tells us that it's going to be a vertical line where x equals -3, and it does have equality. So instead of a dotted, I will do a solid line where x equals -3. And every point on that line will be a solution to that purple inequality. Now I have to figure out a point. Since 0, 0 is not on that line, I can test 0, 0. When I plug 0 in for x, I get 0 is less than -3, which is false. So that means I don't want this point shaded. This is a false, it's not true, which means the points on the other side of my purple line, say -6, 0, -6 is less than or equal to -3, would be true. So this left side of this line would be shaded. Now I don't want this area because none of it will be shaded. Only this side will be shaded and only this side will be shaded. I want where the two parts meet. So everything on this piece of that purple line, everything on this piece of the blue line, and all the points between extending out infinitely will be solutions to this system. Unlike a system of equations which has one point, at least our linear equations, that we have to list as a specific solution, a system of inequalities is all points that make the inequalities true. Feel free to please take a moment to try letters A and B, and we will go over the specific answers to these in class tomorrow. You'll be able to compare with your group members. Have a great day.